Welcome back to Fact Fusion Network, where we explore the fascinating world of science and chemistry. Today, we're diving into the world of noble gases, a unique group of elements that seem to be in a class of their own. Have you ever wondered why noble gases like helium, neon, and argon hardly ever react with other elements? Well, you're about to find out. In the far right column of the periodic table, you'll find a group of elements known as the noble gases. These elements are helium, neon, argon, krypton, xenon, and radon. They are called noble because, like nobility of old, they tend to keep to themselves, rarely forming bonds or reacting with other elements. From helium in party balloons to neon lights that brighten up city streets, noble gases are all around us, but you might not notice them because they're incredibly stable and unreactive. What makes noble gases so special? So, why do noble gases behave this way? The answer lies in their atomic structure. Every atom has a nucleus made up of protons and neutrons, with electrons zipping around the outside in regions called energy levels or shells. These shells can hold a specific number of electrons, and the number of electrons in the outermost shell, or the valence shell, determines how reactive an atom is. Now, here's the key: noble gases have full outer electron shells. Helium, for example, has 2 electrons, which completely fill its outer shell. Neon has 10 electrons, with a full outer shell of 8 electrons. When an atom's outer shell is full, it doesn't need to gain, lose, or share electrons with other atoms. It's already in a perfect, stable state. This is the primary reason noble gases rarely form compounds or react with other elements. Their goal of having a full outer shell is already achieved. Noble gases in everyday life. Even though noble gases don't react with much, they play important roles in our everyday lives. Let's start with helium. It's not just for balloons. Helium is also used in medical MRI machines and in scientific research due to its low boiling point. Neon is famous for its bright, vibrant colors in signs and lighting. When an electric current passes through a tube of neon gas, it emits light, giving us those iconic neon lights we see in cities around the world. Argon, another noble gas, is used in welding to create an inert atmosphere. It shields the metal from reacting with oxygen and nitrogen in the air, which can weaken the weld. Rare reactions of noble gases. So, while noble gases are mostly non-reactive, are they always completely inert? The answer is, surprisingly, no. Under extreme conditions, some noble gases can be forced to react. For example, xenon and krypton, the heavier noble gases, have been known to form compounds when exposed to high pressure and temperature. Scientists have synthesized xenon fluorides, like XeF2, where xenon is forced to share electrons with fluorine. But don't expect these reactions to happen naturally. It takes a lot of effort to make these compounds. Even with these rare exceptions, noble gases mostly stay true to their nature, keeping to themselves and maintaining their stability. Why noble gases are important to chemistry? Noble gases have taught us a lot about chemical stability. They're a perfect example of what all elements strive for: a full outer shell of electrons. This octet rule, as it's called, helps explain why most elements react in the first place. They're all trying to achieve the same stability that noble gases already have. By studying noble gases, scientists gain insights into why other elements form bonds, how reactions work, and the fundamental nature of chemical stability. So, there you have it. Noble gases are fascinating because they've already achieved the chemical stability that other elements crave. Their full outer electron shells make them almost completely non-reactive, allowing them to play unique roles in everything from neon lights to high-tech science. Thank you for joining us today on Fact Fusion Network. If you enjoyed learning about noble gases, don't forget to like this video, subscribe to the channel, and hit that notification bell so you never miss out on our latest science videos. See you next time.